So for question number 8 in this case is asking us to find the sum of the series. So if we want to find the sum of the series, there's only two series that we can really turn to, geometric and telescoping. In this case, this series does not have the form of a geometric series. It has to be some kind of number to an n power. We have 2 over n squared minus 1, so it must be telescoping somehow. But let's see if we can figure out how. So if I have an n squared minus 1 on the bottom, I could easily rewrite this series from n equals 5 to infinity, 2 over n minus 1, n plus 1. Now I have 2 independent linear roots on the bottom, which means that I can split it using partial fractions. So if I want to split that term using partial fractions, I just have to write it out in its form. So 2 independent linear roots means that I just get constants on top, n plus 1. Now I just need to solve for a and b, so I can solve both of them using cover-up method because they're both independent linear roots. So if I go ahead and plug in n equals 1, I cover up for here, 2 over 2, a is equal to 1. If I plug in n equals negative 1, cover that up, 2 over negative 2, b is equal to negative 1. So I end up getting my new series, n equals 5 to infinity, of 1 over n minus 1 minus 1 over n plus 1. Okay? Now I have 2 terms that I'm comparing in this case, so this can be a telescoping series. Now all I need to do is write out my terms and see if I can get an expression for the partial sum. So I'm going to start with my n equals 5 term. If I plug that in, I get 1/4 minus 1/6. If I plug in my n equals 6 term, I get 1/5 minus 1/7. Keep in mind the reason I'm starting at n equals 5 is because the counter starts at n equals 5. So you always have to start at whatever the counter is. N equals 7 is 1/6 minus 1/8. So that term cancels. My n equals 8 term is 1/7 minus 1/9. That term and that term. I have n equals 9, 1/8 minus 1/10. That term and that term cancel. So I'm starting to see a pattern here. It looks like these terms will never go away, and I'll always be left with 2 additional terms here that I need to find the definition for. So if I can find the definition for that, I should be okay. So my partial sum is equal to my 2 residual terms, 1/4 plus 1/5. Then my last terms down here, I know that I'll always have a negative 1 over n plus 1, but in addition to that, my final term will always be 1 before it. So what I'll be left with is negative 1 over n plus 1 minus 1 over n. So this is my 1 over n term. So what that basically says is that if I plug in any n value in this case, I should always get those terms. So if I plug in n equals 9, I get 1/4, 1/5, 1/9, and 1/10. So therefore this partial sum is the correct expression that we need. So again, the reason I got that is just from looking at these terms and figuring out how they fit into my n values, or my expression. So again, 1 over 10 is my negative 1 over n plus 1 term. My 1/9 is 1 over n because it's always one n term before it. So now, to find out what my true sum is, all I have to do is take the limit of my partial sum as n goes to infinity. And if I do that, these 2 terms end up going to 0, so I end up getting 1/4 plus 1/5. So according to that, if I go ahead and add those together, find a common denominator, I end up getting 9 over 20. So 9 over 20 is the sum, which means that the answer is B. And on a side note, because I ended up with a finite sum, that means that this series is convergent.
The Teaching Center, UF's Learning Resource Center.